All right, hello. Welcome back to 9.4 circuit types. This is actually 9.4b video. Today what we're going to be doing is we're going to be going through parallel circuits and how to solve for current, voltage, power, dealing with a parallel circuit. So the first thing we want to do is let's go through some of the things that are different from a series circuit. So the big thing here is our voltage will remain unchanged. So our voltage will be whatever the battery is. So if the battery was 10 volts, then the voltage will always be 10. If it's 120, it will always be 120. If it's 300, it will always be 300. So the voltage is not going to change. Current, however, is the sum of all the currents. So there's multiple paths, so there's multiple currents. So it can go, this way, or it can go this way. So two different paths, parallel circuit. What we're dealing with is multiple currents. But they should add together to give you your total current. Very similar to how voltage drops did in series circuit, only now we're dealing with current. The big thing that's going to be kind of weird and funky is this. Resistance. So our resistance total, in order to find our resistance total, what we have to do is take the reciprocal, so 1 over the resistor, and add those together. And I'll show you how to do that. But after you're done adding them together, you have to flip it back around again. So you have to take the reciprocal, add them together, and then take the reciprocal again. I know, it's a little weird, but it's okay. All right. Let's go ahead and do a practice problem. First thing you want to do is identify what type of circuit it is. So there is 1, 2, 3 ways for the electricity to flow. So therefore it is a parallel circuit. And I should remind you, or at least state, that you can have a series and a parallel circuit in the same circuit. But for right now we're going to keep them separate. Okay, so let's go to our RVIP chart. So resistance, voltage, current, and power. Resistor 1, 25, resistor 2, 50, and 100. Now define resistance total. We cannot just add them together like we did in our series. We have to first turn them into fractions, add the fraction together, and then take the reciprocal again. So 1 over 25 plus 1 over 50 plus 1 over 100. All right? So there's 2 ways you can go about doing this. The first is find the least common denominator. So in this case, it would be 100. So 4 over 100 plus 2 over 100 plus 1 over 100. And that would equal 7 over 100. Then you would take the reciprocal, 100 over 7, and you would come up with something around 14.28. So that's the first way. The second way is a little bit easier. What you can do is go ahead and plug this directly into your calculator. So 0.04 plus 0.02 plus 0.01 gives you 0.07. So plugging them in, if you plug in 1 divided by 25, it gives you this decimal. It's 4/100ths. And then you can add them all together without finding the least common denominator. That's fine, but you still have to take the reciprocal. So you can remember that's 7 over 100, because that's what 7/100ths is. Or what you can do, that might even make it easier, is just take the number 1 and divide it by whatever decimal place you get. So in this case, 1 divided by 0.07. And you will get 14.28 as well. Alright, voltage. So since this is a parallel circuit, the voltage doesn't change. So 120, 120, 120, 120. You can fill those in all the way. And hold on just a second. Mr. Kim's here with my Mountain Dew. Alright, back to business. Okay, so current. So we're going to use Ohm's law. Let me change the color here on us so we can use that. Ohm's law, again, is current equals voltage divided by resistance. So what we can do is just take our voltage, 120, and divide it by 25, take 120 divided by 50, take 120 divided by 100, and then add all those together. So you should end up with something like wrong color, purple. Okay, 4.8, 2.4, that was really weird, 1.2, and 8.4. Alright, and then when it comes to finding power, again, you can use any one of these to find power. This one is probably going to be the easiest, current times voltage, since we have all the currents now. So 4.8 times 120, 576, 2.4 times 120, 288, 144, and then the total of 1008. Sweet! We should notice that the amount of power that we get out of a parallel circuit is much greater than what we got for our series circuit, like 11 times greater, so that's cool. That's a good fun fact. Alright, I think that's about all I got for you for today. So I'm going to sing a little Vanilla Ice for you. Stop! Collaborate and listen. Ice is back for a brand new edition. Okay, that's all I got. I'm just joking. I'm not going to keep going through that. Alright, I'll talk to you later. Bye.